Good evening, friends. Good evening, channel subscribers. So, this is a sudden live, but actually, the class is scheduled for the ongoing black belt and the green belt batch. So, this particular session, I will be discussing about few important topics. Good evening, friends. Good evening, channel subscribers. Oh, that is going echo. So, this is a sudden live, but actually the class is scheduled for the ongoing black belt and the green belt batch. This particular session, I will be discussing about two important topics. I think it is going back. Let me figure out how to adjust it. Yeah. Live is going on. All right. Anyway, the topics for discussion today is we will be understanding the difference between descriptive statistics and then inferential statistics. That is one thing. And I want all of you to gain a absolute clarity on the difference between normal distribution and then standard normal distribution. And in the process, you will also understand the difference between sample and then population. All right. I think now it is perfect. Am I properly audible now? I think there are no echoing right now. Am I correct, Mr. Narendra?
Yes, sir.
Yes, sir.
Hello, Santosh. Good evening. Welcome.
Yes, sir. How are you? Good evening, sir. Thank you, sir.
I'm doing good. That the others will be joining. Okay, so before others are joining the meeting, so you can ask your specific questions. I will be happy to clarify. Before that, I'm just live streaming this meeting in the channel also, so that you people can go back and watch it again. So let me brief the idea of the meeting. The idea of the meeting is to discuss few topics with the ongoing Six Sigma certification program participants. One is understanding the difference between descriptive statistics and then inferential statistics. And then another idea is to understand the difference between normal distribution and then standard normal distribution. And also using Minitab software, how to calculate the probability. And if we get time, that is, the session is planned for 1 hour. If we still have time, we'll also talk about the difference between sample distribution, then population distribution, and then sampling distribution. There are 3 types of distribution generally exist. So what is the difference? So this is the idea. So I welcome all the participants for the meeting as well the channel subscribers. So I hope the session is going to be productive and helpful to all of you. Okay, with that note, so any questions? First of all, the first opportunity to people who are here in the meeting. Any questions? Narendra, do you have any doubts? Yes, please.
Yes, sir. I have doubts, sir. Sir, what is difference between mean, medium, and mode, sir?
Oh, good question. What is the difference between mean, median, and mode?
Yes.
So mean is average, right?
Right, sir.
In order to calculate the mean, whatever is the number of data you have to use all the data. Let us say you have 100 data point. Add all 100 data point and divide by 100, you get the mean or average. You understand?
Okay, sir. Yes, sir.
Average will be the best measure of central tendency. whenever your distribution is symmetric and unskewed. Symmetric and unskewed. Skewed means the bell-shaped curve will be twisted either to the right side or to the left side. If the bell-shaped curve is twisted to the right side or left side, then the distribution is called skewed distribution. Understand?
Yes, sir.
Whenever your distribution is skewed, then mean may not be helpful. Mean may not be helpful. Under such situation, you must go for median. You must go for median as the measure of central tendency. So how to get the median? You have to arrange the data in either ascending order or descending order. You have to arrange the data in either ascending order or descending order, and then you should locate the number that is there in the center. You have to locate the number that is there in the center. So that center number is called median. For example, let us say I have 1, 2, 3, 4, and 5. 5 numbers I have. Now when I arrange the number in increasing order, then it is the same thing. 1, 2, 3, 4, and 5. What is the number you could see in the center?
3 number.
3 is the median.
Yes, sir. Median.
Right? Suppose I have 6 number. 1, 2, 3, 4, 5, 6. Now what is the number there in the center? 1, 2, 3, 4, 5, 6. There are 2 numbers are there in the center, isn't it? 3 is also there. 4 is also
and
there.
4 are also. Okay.
Now 3.5 is the median.
Okay.
How do I get 3.5?
Is the median.
The center
3.5.
Center of 3 and 4. Center of 3 and 4, isn't it? So
Yes.
just take the average and you will get the 3.5. So always median is the central value. Always median is the
Central
value. And when the median will be helpful?
Yeah.
When your data is not normal, or when your data is skewed.
Skewed.
For example, tell me, in your company, how many employees are there?
300 employees, sir.
300 employees are there. What is the average salary?
Average salary maybe, sir, 20,000.
20,000 rupees is average salary. But now, do you think the salary range is normally distributed or the abnormally distributed? For example, the lower people, maybe huge numbers of people may be there at the down level, isn't it?
Yes, sir.
For them, the salary is below 20,000.
Right. More than.
And moderate size people will be there. For them, the salary range is maybe 35,000 rupees. But very few number of people, they might earn in terms of lakhs. Isn't it? Few people will be earning more than 70,000 and more than a lakh. That means the distribution is not normal. Now, asking you the question, the average salary is not actually the central tendency. I should ask you the median salary.
Median salary.
Why I should ask median salary? Because the distribution is not normal. Normal means exactly 150 people should have salary above 20,000. Exactly 150 people should have salary below 20,000. There has to be some symmetry of distribution. There has to be some symmetry of distribution. And that is the first property of normality. So if the data is not normal, we should go for median. Understand?
Understand.
Now one more example. Let me give one more example. 1, 2, 3, 3, 3, 4, and 5. Now how many number I have told now? 1, 2, 3. One more 3. 3 times 3. 4, 5. Totally how many numbers are there?
7 number.
How many numbers?
7.
7 numbers.
Right.
Now out of the 7 number, is there any number which has occurred many times?
3 number.
So 3 is the mode.
3 is the mode.
3 is the mode. The most frequently occurred number is called the mode. Do you understand?
Yes, sir.
Now there is mean, there is median, there is mode. When to use mean? When the data is normal. When to use median? When data is not normal. When your data has lot of outliers. When your data has lot of outliers. Outliers means values which are far away from the average. For example, in your company, you said few people are drawing salary of 1 lakh. But where is 1 lakh? Where is 20,000? Distance is too high. Am I right?
Right, sir.
So the 1 lakh is an outlier. When all the salaries are around 20,000, let's say 20,000, 19,000, 21,000, these are all normal. But 1 lakh is abnormal. So when you have outliers present in your data, you must prefer to look at the median to understand the central tendency. All right. And now you are doing a survey. You are doing a survey, right? And now according to the survey, like for example, for the training program, you are asking the feedback of the participants. Some people are saying, the feedback is, the training is excellent. Some people are just telling that the training is very good. Some people are telling that the training is good. Some people are telling that the training is bad. And some people are telling that the training is very bad. So there are 5 options. Now 100 people you are asking. Out of 100 people, 70% of the people or 70 people, they say that the training is excellent. Say that training is excellent.
Excellent.
Another 10% of telling that the training is very good. All right. And now 80%
Right.
over. And now 5% of the people are telling that the training is good. Right. And now what is the remaining percentage available? 70, 10,
80.
85 over. Now,
Yes.
7.5% of the people are saying that the training is bad, and another 7.5% are saying that the training is very, very bad. Now, what is your conclusion? What is your conclusion? The training is good or bad? Excellent.
Training is excellent, sir.
Why?
Because
Go for the majority.
70% people, more than people are in favor of the training.
Because excellent has appeared 70 times.
Yes, sir.
Excellent has appeared 70 times, and very good has appeared 10 times. Good has appeared 5 times. Bad has appeared 7.5 times, and remaining 7.5 times very bad. So the most frequently occurred data is excellent. So the training must be considered as an excellent program. Do you understand? Now, which is helping us to understand the effectiveness of the program? Is it the mean or median or the mode in this case?
Mode.
In this case, mode.
Mode.
Now, if you look at our data is not a number. Our data is not a number, isn't it? Our data is attribute data. When you don't have number, your data is called attribute number.
Attribute.
Whenever your data is attribute, mode can help you to understand what is happening. Mode can help you to understand the central tendency. Do you all understand when the mode comes into picture? All of you?
Yes,
both
sir.
of you?
Yes, sir. Yes.
When the data will be attribute type.
When your data is attribute. Let us say, hello, welcome Sundar. Yeah. Let us say, you are in a heavy traffic area. Lot of vehicles are passing on the road. Within 1 hour, within 1 hour, 100 buses have crossed your signal point. How many buses? 100 buses.
100.
And within the same 1 hour, near about 300 auto, right? The 3-wheeler auto, right? So the 300 autos have crossed. and more than 700 two-wheelers have crossed the signal point. Now tell me, what kind of vehicles? Someone is asking, what kind of vehicles are crossing the signal point? Do you think the vehicles that are crossing the signal point will be will it be two-wheeler, or will it be three-wheeler autos, or will it be the passenger buses? According to your data, what kind of vehicle you can expect to cross the signal point? Will it be two-wheeler, or will it be three-wheeler, or will it be, let us say, four-wheelers? Do you get my question, or understand the situation? You are standing in a signal point. Within 1 hour, 100 four-wheelers have crossed. Within the same 1 hour, 300 three-wheelers have crossed. And within the same 1 hour, near about 700 two-wheelers have crossed. Now, what is your understanding now?
More two-wheelers.
Two-wheelers are more, isn't it?
Yes, sir.
So next 10 minutes, if you stand in the same place, which vehicles will cross the signal point in most of the time? Will it be two-wheelers, or will it be more three-wheelers, or will it be four-wheelers? Which will be more in number?
Two-wheelers.
Two-wheelers.
What is going to happen? The message is conveyed by the mode again. Do you understand?
Yes.
So, because what kind of data we have? There are three types of data. What we observe is either two-wheeler, or three-wheeler, or four-wheeler. This is an attribute data. Two-wheeler appeared most of the time. So the number that appear most of the time is actually called the mode. Hope all of you understand, right? So now,
Right.
do you all see my Minitab screen? All of you? Please confirm.
Yes, sir.
Yeah.
Visible.
Yes, sir.
Visible, sir.
You can see the Minitab screen. Now let me type
Yeah.
some numbers here, or let me open. Okay, let me type some numbers here. 8, 12, 9, 7, 11, okay, 6, and 13, 15, again, like 8, and one more thing. Okay, 14. So do you see a lot of numbers here? How many numbers I have typed?
10 numbers.
10 numbers, right? So let me call it as data. And now with the 10 numbers, I want to calculate the mean and many things. Go to stat, go to basic stat, display descriptive statistics. What is this? Display descriptive statistics. And now I select the data. I have selected the data. Now what are the statistics that are required? Now can you read, one of you? Can you read all these things? So many statistics are available. You need to learn them so that you can use. What is this available?
Mean.
So let me tick the mean. So the Minitab will calculate the mean for us. And then what is next?
SE of mean. What is
Yes.
it?
SE of margin.
SE means standard error of mean. So you need to understand what is standard error of mean. Then only you can tick this. Then only you can use this. Since we don't know about standard error of mean, I'm not going to tick it. But standard error of mean help us to understand the confidence limit. Help us to locate the confidence limits. Anyway, I'm going to leave it. Standard deviation. Hope all of us are familiar with standard deviation. So I tick standard deviation. Then variance. What is variance? Variance is square of the standard deviation. Am I correct? So I tick variance also. Coefficient of variation. This Dr. RK will teach you tomorrow. What is this? Coefficient of variation. This Dr. RK will teach you tomorrow. And then trimmed mean. What is this? Trimmed mean. I am going to round off the mean by trimming a small portion of it. Let me see what comes. I am ticking this. Sum means, all of you, do you know the meaning of sum?
Add करना सर. Add.
Summation.
Addition.
Just add all the values. Minimum,
Yes.
all of you, do you know the meaning of minimum?
Lower
Okay.
lower value of the.
You just say yes. If you say yes, I'll tick. Maximum?
Yes, sir.
Okay.
Maximum data.
Range? Range, all of you, do you know range? What is range? The difference between maximum
And minimum.
and minimum. So range is known. And n means total number of data. N means total number of data. Median, just now we discussed, am I right? Median. So I tick the median. Then you have first quartile, you have third quartile, then you have interquartile range. Mode you have. Okay, I think this many is enough right now, initial stages. Let me give OK and give OK again. Minitab will calculate all these things for me. Can you all see the data here? I mean, some report here.
Yes, sir.
Total count. How many data is here?
10 data.
And the mean value is 10.30. Trimmed mean 10.250. How much value we have trimmed? 0.05 we have trimmed, isn't it?
Yes.
So that is trimmed mean. Standard deviation is 3.129. Square it. That is the variance. When I square the 3, it becomes 9. Do you get the point? Yes or no? I want all of you to be participative and no.
Yes, sir.
Yeah.
Standard deviation square is variance.
Variance, that's all. And sum means the addition. You add all the value.
Addition.
Minimum is
Okay,
6.
Sir, can you repeat that point, sir?
Which point?
From the trim only, sir.
No, trim is not, mean is 10.3 and 10.3.
Got it, sir.
And trimmed mean means, no, I just round it to a nearest value by trimming whatever value I want.
Oh, okay, sir. Okay, sir.
0.05 is trimmed.
Okay, sir.
0.05 is trimmed, and so it becomes 10.25.
Okay, sir.
And this is standard deviation, and square of the standard deviation is variance. Sum means sum of all the value. You add all the numbers. Minimum is 6. Median is 10. Look here, median is 10. When I arrange the number in either ascending or descending order, the 10 is actually appearing in the center. Without you, working for it, it is giving you. And the maximum is 15. Range is 9. And then mode is 8. Oh, really? Mode, anyway, 8 appeared 2 times. I think even I didn't know that. Yes, 8 appeared 2 times. So that is why it is saying n for mode is 2. All of you, do you understand now?
Yes, sir.
How we did it? We should go to stat. Then
Basic statistics.
basic statistics. Then
Display descriptive statistics.
very good. And then select the
Select data.
very good. And then
Select.
go to statistics. Whatever required, you can select. But before selecting, you should be familiar about the meaning of it, isn't it? Because if there is no meaning, what will you, if you don't understand the meaning, you can't, use the statistics. So only whichever we are familiar, I have selected now. But as we progress through the training program, you will be familiar with all those things, right? And tomorrow also, Dr. RK will be teaching you few additional statistics. So gradually, you will be very familiar with all the statistics. Okay.
Sir, may I ask what is n for mode, sir?
Yeah. N for mode is, what is mode first of all here?
Mode is 8. It has been
Yes, sir.
repeated 2 times.
The data is repeated.
Number of time a statistic gets.
It is, how many times 8 is repeated? Can you see?
Okay, that one. Okay.
That's all,
2
right?
times.
Very
Okay,
good.
sir.
Yes.
So,
Clear, sir.
very good. So now this is called descriptive statistics. Now say go to stat, go to basic stat, go to stat, go to basic stat, go to graphical summary. Column 1, you select and again give OK. And now there is a graph coming. This graph is actually called histogram. This graph is actually called histogram.
Histogram.
if you look at this graph, it is more or less normal, more or less normal, but it is difficult for you to understand that it is following a bell shape because we have two less data. We have two less data.
less.
We have at least 100 data point. Then the bell will automatically form. Bell will automatically form. But then also Minitab has predicted that the data is normally distributed, right? And again, mean is available, standard deviation available, variance available, all few other informations are available. We'll come to this little later. All right. So far good, all of you?
Yes, sir.
Yes, sir.
Very good. So now I want you to go to this graph. What is this? Probability
Distribution.
distribution.
Plot.
Pilot.
This function will help us to view and compare the shape of distribution. This function will help us to
Shape
view
of the distribution.
and compare the shape of distribution. The same function will also help us to calculate probabilities. Calculate probabilities as well the associated values of the variable. Let us see how we can use this, right? Probability distribution plot. The last one, view probability. Okay. Now what distribution you want to see? What you see here, so many distribution, can you see?
Yes, sir.
Beta distribution, binomial distribution, Cauchy distribution, chi-square distribution, discrete distribution, exponential F distribution, gamma, geometric. So many distributions are available, but I don't want to trouble you with all this distribution. Please master one single distribution, which is normal distribution.
No.
If you know one single distribution, you can solve even problems related to all other distribution. You will understand the secret after learning a theorem called central limit theorem. What is the theorem? Central limit theorem. If you understand central limit theorem, this one single distribution can allow you to solve problems related to all the other distribution, right? That is the reason why we stress upon the normal distribution. So select the normal distribution. Any normal distribution will have a mean value, will have a standard deviation. Am I correct?
Yes, sir.
For example, consider people in India in the age group of 25 to 45. I think all of you are in that age group. Am I right?
Yes, sir.
People in the age group of 25 to 45. What could be the height of people in India in the age group of 25 to 45? Average height of the people in India. Will they be 5.5 feet?
Yes.
Yes, sir.
Very good. All of you agree? Right. And now,
Right.
the standard deviation is found to be 0.25 according to the data that I am assuming. So from the population, I have taken a sample. The sample average is how much? 5.5. Standard deviation is how much? 0.25. Now, after giving all these things, I go to shaded area. And now I want to calculate the probability. I want to calculate the probability between 2 points, right? So first point, I come to this thing. What is that? The last graph. Here 5.25. Here 5.75. When I say 5.25, how do I get this? Average minus 1 standard deviation. Am I correct? 5.75 means average
plus 0.25.
1 sigma minus 1 sigma plus. Now what is the probability for an individual in India in the age group of 25 to 45 to have a height between 5.25 and 5.75? Do you understand? When I meet 100 people, in India in the age group of 25 to 45, what percentage of the people will have the height in this range? Will you be able to make any guess now, all of you? Anybody? Any guess for your answer? Come on.
Most of them.
Most of them will be in this range, right? So let me see what percentage it is. Do you see the graph? Red color area.
Yes.
Yes, sir.
So what percentage of the people are in the age group of what percentage of the people in India in the age group of 25 to 45 are having the height between 5.25 feet and 5.75? What percentage?
0.68.
0.68 is number. Percentage wise 68.27.
0.27.
If you come across 100 people, approximately 68 people will have the height between 5.25 and 5.75. Do you remember we also studied the property of normal distribution? 68.27%
Yes,
of
sir,
the data will lie between 1 sigma limits from the center. That is why I chose 1 sigma limit. All of you understand here?
Yes, yes, yes.
Now let me go to graph again, probability distribution plot again, view probability again. Now same conditions, shaded area, the last one, but now I am reducing it to 5.0. Here, can you tell me what will be the value I will put?
0.
6.0. Now, how many standard deviation away from the center is pi?
2.
2 standard deviation away from the center. This 6.0 is also 2 standard deviation
Higher.
above the center.
Above.
Now, what do you think? What percentage of the people will have the height between 5 feet and 6 feet? What percentage?
95%.
95.
Now tell me, all of you are in the age group of 25 to 45, all three? Some of you are not on video, so I am not able to guess your age.
Yes, sir. Yes, sir.
All of you are in this range only.
Yes,
And now all of you are falling in this height range between 5 feet and 6 feet.
Yes, sir. Yes, sir.
That is the beauty of normal distribution. Even with a smaller sample group, it is working. What is the theorem is saying? Distribution is saying at least 95% of your data will fall between 2 sigma limits. It is, we have directly, seen it with your height. And now let me go for the third graph. Probability distribution plot, view probability, okay, and same values. You should know the mean and standard deviation, right, in order to find the probability. Now come to the shaded area, X value, and now what should I put here?
4.75.
Very good. So here I will put 6.25. What do you think the probability will be?
3 sigma.
So the value, look at the value, how much it is? 99.73. If you randomly select 100 people in the age group of 25 to 45, the theorem is saying all of them will definitely have the height between 4.75 feet and 6.25 feet. Do you think this is logical and realistic?
Yes, sir. Yes, sir.
Yes, sir.
That is the beauty of normal distribution. That is the beauty of normal distribution. Now, if you know
Sir, may I ask something, sir?
Yeah, I'll come to your question. If you know the X value, probability will come. If you know the probability, X values will come. Do you understand?
Yes.
If you know if we have given the X values and Minitab has given me the probability, the reverse is also possible. If you give the probability, Minitab will give what you call the X values. So I will explain that. Meanwhile, I think Santosh wanted to ask me a question, right?
Yes, sir.
Yes, Santosh, what is your question?
Sir, what do you do if you are considering 6 feet to 7 feet for this 100 people? What would happen for the graph?
Okay. So 6 feet to 7 feet. Very good. So go to graph. Probability distribution plot. View probability. Okay. This is the mean and standard deviation. Shaded area. And you said 6 feet, right? Put 6 here. Put 7. Now what is your guess right now? Santosh, you asked the question. When the mean is 5.5, standard deviation is 0.25. Do you think you will be able to see too many people in this height range?
No, definitely not.
So let us see what Minitab is giving. Okay. And can you see
Yes.
what percentage of the people will have the height above 6 feet?
2%.
Negligible.
2%, just 2.27.
Okay.
You understand how the probability is, or everything depends on two things only. What are the two things? Mean,
Mean standard deviation.
that's all. If the mean and standard deviation is understood, you can calculate the probability. And your predictions will be perfect if your data follows bell-shaped curve. Because all the values are calculated based on the assumption that the shape is inverted bell, which is called normal distribution. Clear to everyone? Now let me do one more thing. Graph, probability distribution plot, view probability, okay. And this is same, shaded area. Now, instead of giving the x value, I will give the probability. I will give the probability, and now I want to get what you call, I will give the probability and I want to get the x values, right? We will do it that way. And now the left side probability, right side probability. Will you be able to give me the left side probability and right side probability in this manner? P1, P2, or let us go for symmetrical, right? Left side of probability, right side of probability. Now I am going to say within 1 sigma, what percentage of the area will lie? Please answer.
60.
Within 1 standard deviation from the center, what will be the percentage of the curve?
33%.
See, 1 standard deviation right side, 1 standard deviation left side. So the area will be 68.27. Am I correct?
Yes, sir.
So
Half of it.
outside of the area will be 31.73. Am I right?
Yes, sir.
See, look at the graph I have selected. It is showing inside area or outside area. Look at the gray color.
Outside area.
Inside area.
Outside area. So 68.27 is inside. So outside is 31.73. That 31.73 is equally divided into both sides. Am I right?
Yes, sir.
So 31.73 divided by 2. So this will be 15.865 or 7, right? 865 to be precise. Now I am giving you okay. Oh, sorry, 15.265. I should give it like 0.15865. And now I give okay. Now look here.
Mean is 5.5.
5.5. And okay. Wait. It has divided into equally. All right. Then what I will do is just a second. Graph, probability distribution, view probability. Okay. Go to shaded area. Take this. Let us give the outside area. Outside area is how much? 68.27 minus 100, or 100 minus 68.27. It is coming to 0.3173. So it will divide into 2, right? 0.3173 is the outside area. Can you see here? Exactly 5.25 and 5.75 automatically coming out. Do you understand? Because the inner area is how much? 68.
68%.
Outer area we have given as 32. So if you know the probability, the x values can be determined. If you give the x value, probability can be determined. The requirement is you should know the mean, you should know the standard deviation, you should know the type of distribution. What is the assumption here? Distribution is normal.
Normal.
All of you are good so far?
Yes.
Now I want you to go to graph, go to probability distribution, go to view probability, give okay. Now, in the mean value, I am going to say 0. In the mean value, I am going to say 0. Do you think mean value will become 0? Possible or not possible?
Not possible.
So this is an ideal, ideal condition. This will never happen. So mean is 0 and standard deviation is 1. Mean is 0, standard deviation is 1. When you assume mean equal to 0, standard deviation equal to 1, now the resulting distribution is called as standard normal distribution. All of you, do you understand when a normal distribution will be called as standard normal distribution? A distribution
When mean becomes 0.
when mean becomes 0 and standard deviation becomes 1.
Yeah.
All of us are human being, am I right?
Yes, sir.
Do you think we all will become a god one day?
No.
How can the mean be 0?
We will never become god, isn't it? But if you become, very kind to everyone, you have become, very, helpful to everyone around you, and everyone literally loves you, then you start appearing like a god. But it never happens, isn't it? Something like that. Your mean, when it becomes 0, when standard deviation becomes 1, now the distribution or the normal distribution will be renamed as standard normal distribution. Clear? Do you want to see how the standard normal distribution will be? You want to see the God?
Yes.
Yes, right? So let me show you the God, right? So now you should also give some points how the normal distribution will look like. And now let me give the point. See, earlier we were giving the point, by knowing the value 5.25, 5.75, isn't it? Now you don't have to remember anything, because what is there in the center?
0.
0. So left side is
Minus
minus
one.
1. Left side is minus 1. Sorry.
Minus 0.
Come. Wait. Why it is not accepting minus 1? Oh, 0.
Okay.
Okay. Left side is 1. Right side up. Okay, sorry. Let me take x value. Select x value. Minus 1. Right side is plus 1. When left side is minus 1, right side is plus 1. What was our understanding from the normal distribution? What is the probability of area inside minus 1 and plus 1?
0.
Not 0.
68.
The same thing will come. See here. Can you see the red color area 68.27?
Yes, sir.
Distribution also gave the same value. Standard normal distribution also gave the same value. But in normal distribution, in the x-axis, the actual values will be there. But in standard normal distribution, you will have G-score. What will you have?
G score.
G-score. X is replaced by G-score. When the mean is converted into a G-score, you will get 0. Because what is the formula for G-score? The difference between the observed value and the target value divided by the standard deviation. So according to that, the mean is converted into a G-score, and that G-score is 0. And now standard deviation is 1 on the right side, 1 standard deviation on the right side, 1 standard deviation on the left side. The area is same. Suppose when I go for 2 standard deviation on the right side, 2 standard deviation on the left side, what will be this area?
95%.
Beautiful. Graph, probability distribution, view probability, okay. 0 on 1. 0 1 means what is the normal distribution? Is it normal or standard normal? Come on, answer this question.
Standard normal.
Standard normal distribution. Very good. Shaded area, x value. Instead of minus 1, I give minus 2. Instead of plus 1, I give plus 2. Now, what is the probability of area expected between minus 2 and plus 2?
95%.
You can see that here, 95.45. If somebody is asking you a question, you always cleverly answer. There is 95% chance for your value to fall between this limit and this limit. Am I correct? If somebody is asking you, what is going to happen tomorrow? Let us say you want to know how much Virat Kohli will score in the next match. Will you tell a single value? You will always tell two values, isn't it? He'll score between 30 to 40 runs, he will score. Am I right? Yes or no?
Yes, sir.
Yes, sir.
So
Yes, sir.
the one value is the left side value, the other value is the right side value. And you will also say that there is 95% since Virat Kohli hit the century as last match, then in the next match, he will definitely score between 40 to 60 runs. And you are 95% confident. How are you saying 95? How are you saying that your confidence is 95%? Because it is as per the normal distribution. And now you have to tell me the probability for the last thing. View probability. Okay, it's a standard normal distribution. Shaded area -3, and here it is +3. What will be the area between -3 and +3?
99.75.
99.73. Can you see that here? Is it easier?
Yes.
Sir.
Right?
Yes, sir.
So start.
But in which scenario such
Sir.
values happen, sir?
You tell me a scenario. You tell me a scenario. In all scenario, you can use it. Say, for example, these are the test marks of your children.
Okay.
Right? Your child has scored like this. 10 examinations were conducted. Let us say, no, let us consider the mark as good. Out of 15, 15 is the maximum mark. How much is the maximum mark?
15.
15, and your child did well in certain subjects, like 15 out of 15 and all those things. Now you want to know what could be the mark of your child, right? Probably in the upcoming examination or something. Let us go for, what do you call, graph, sorry, stat, basic stat, graphical summary. This is the data. Okay. And now one of you please remember, what is the mean score of the children?
10.3.
What is the standard deviation?
3.12.
Please remember this, right? You have to tell me. Go to graph, go to probability distribution plot, view probability, okay. And now the distribution is normal. How to determine the normality right now? The eye judgment. Eye judgment is normal only. But if you have a doubt, then you should go for a statistical procedure, which I will explain later. Now, what is the mean value we observed? 10 point?
30.
300.
What is the standard deviation we observed?
3.12.
19.
3.129. Now, shaded area. What is the probability of my child to score between 9 mark and 12 mark? Okay? Shall we find out?
Okay.
Let me give okay. What is the probability for your child to score between 9 and 12 in the upcoming exam? What is the probability?
26%.
Nice.
Only 36% chance is there for your child to score between 9 and 12. Do you understand? Do you get some information about your child performance now?
Yes, sir. Yes, sir. Yes, sir.
Now I want to know what is the chance for my child to score above 12. Graph, probability distribution, view probability, okay. Mean and standard deviation already declared, shaded area. So above 12 means, now which graph I should choose? Above 12 means first one, second one, third or fourth?
First one.
Very good, first one. Here I will say 12. What is the chance for my child to score above 12 in a 15-mark test, in a 15-mark exam? What do you think? The chance is too high or too less?
Less only, sir.
Let us see how much it is.
29.
Your child has got 29% chance of scoring above 12 based on the past performance. Please understand. Your prediction is based on the data you have in your hand. All of you understand?
Yes, sir.
Now, what is the chance for your child to score 14 and above? Shall we see that?
Yes, sir.
Graph, probability distribution, view probability, okay. Mean standard deviation, shaded area, and 14 and above. Do you think there is a chance for your child to score 14 and above?
Very, very less.
Very, very less. Good. Let us see how much it is. How much percentage your child has got to
11,
become
11%.
rank number 1 in this class? 11%. Do you understand?
Yes, sir.
If this percentage increases to 80-90%, your child should be a first ranker, isn't it? Isn't it? See, what do you understand? Why this percentage is going down? Because in the data is highly inconsistent. Do you understand? Look at the child performance. Can you see the inconsistency in the performance? Come on, guys, speak with me.
Yes, sir. Yes, sir. Yes, sir.
Then we could see a lot of inconsistency in the performance. That is why our winning chance is going down. How many of you are able to recognize?
A few subjects he scored very less, and few subjects.
Very good. Suppose, let me say, no, in all the classes, no, let me put the test mark as, no, only very high marks. All are 13, 14, 15 only.
And first mark.
Now your child is having, good scope to become, top ranker. Now go to stat, basic stat, graphical summary. You know why I am going for graphical summary?
Well, get the histogram.
I should get the histogram to understand whether the data is normally distributed or not.
Distribution.
Normally distributed. Right now, you assume everything is normally distributed. We will teach you how to check the normality later on. Now the assumption is normally distributed. And now what is the mean?
14.3.
0.3.
14.3.
So 14.3 is the mean, 0.675 is the standard deviation. Please remember this. Graph, probability distribution plot, view probability, okay. So mean is how much? 14.3. Standard deviation is how much?
0.675.
0.675. And now shaded area. Now I want to know the probability of my child to score above 12 marks. What do you think? What is the chance for your child to score about 12 marks? Look at the past performance and tell me.
100%.
100% chance. Let us see whether that happens. Can you see?
99.7.
You are able to now judge the exam score of your children even before the exam. How you are able to judge? Because of the consistency. If consistency is there, predictability will improve. All of you understand my statement?
Yes, sir.
Yes, sir.
Consistency is there, predictability will improve. If predictability improves, you are a powerful decision maker. Am I right?
Yes, sir.
If your decisions are always correctly happening, then you become a leader in your company. You study the market condition. You are giving correct advice to your company, and your company is following your advice. The market share is improving drastically. What will happen to your growth? Obviously, since you are giving the correct directions. How you are giving directions? Based on the available data. And the available data will be, will help you to predict the correct decision, predict the correct happenings if the data is consistent. So that is why, in order to bring the consistency, we establish SOPs. Do you understand? We have SOP, standard work statement, and all those standardization we are doing only to achieve consistency. Why consistency? If consistency happens, predictability will be much better. If predictability is much better, you can always take the very, very correct decision. All of you understand how the knowledge of probability is helping us? Yes or no?
Yes, sir.
Yes, sir.
Now, this is the exam score of your child, right? And now, I have dropped down. Now look here. Now how many data points are available?
900 plus.
900 plus. Imagine all the exam, in the school, there are 900 students. How many students? 900 students.
900.
The marks scored by all 900 students in the entrance examination is available. What is the score? Entrance exam score, right? And this is, now this data is called population. Do you understand?
Yes.
How many students are there?
900.
900 students. All 900 students' exam performance in the entrance examination is available, right? So let me say the maximum mark of the entrance exam. Okay. Okay, not a problem. So the maximum mark is, let it be 100 only. It is something like, tough exam. So the first mark itself is how much? 54 or 53.33. Now this is called population. This is called population. All of you understand? Now randomly, I select some data and I paste it here. Now how many data available?
18.
18.
This 18 data are picked up from the population. Now this is called sample. All of you understand?
Yes, sir.
The first column is population, second column is sample.
Sample.
Now, in the school, though there are 900 students, they are divided into various sections. Section A, section B, section C. Do you get my point? Section A, section B, section C. Section A, there are 100 students. So totally there are 900 students, right? So how many sections will be there?
9.
9 sections.
10 sections. Now in the first section of 100 students, section 1, I have taken a sample. Please see here. 1, 2, 3, 4, 5. Let us say 5 only. So section 1, how many sample I have taken? 5. Now I go to section 2, section 3, section 4, section 5, section 6, section 7, section 8, section 9. Now I go to section 2. Section 2 means below 100 I should go, right? So I'm going to below 100. Yes, somewhere here. Here I use some technique. It's a random technique only. So I just take 5 data and come here. What is this? Section 2. Sample collected from section 2. Sample collected from section 2. Now, what is 3 represent?
300 and above.
Sample collected from section 3. Section 3 is 200 to 300. So 200, I have crossed 200. Now it is section 3. Let me take 5 data. 5 data point. Control C. Now I paste here. Similarly, I go to section 4. Section 4 is 300 to 400. Have I come to 300 to 400? Yes. Let me pick up the data. 5 data point. And then I should go for section 5. Section 5 is 400 to 500. So I have already in 400. Control C. I have come here. Now section 6. 6 means 500 to 600. Now you are going to learn central limit theorem using this. Control C. I should come to 6. Now section 7 means 600 to 700. Coming here, yes. 600 to 700. 5 data point. I come here. Now section 8 means, come on, you can speak with me. Section 8 means 700 to 800, right? So Control C. Yes. Now section 9 is 800 to 900.
900.
Very good. So I have come 800 to 900. Okay, 5 data point. Now, see here, the first column is population. First column is
Population.
population. Go to stat, basic stat, graphical summary. Take column number 1. Okay. Now, what is the distribution you are seeing? Population distribution. What is this distribution called?
Population.
Population distribution. What is the population mean?
Number of person.
Total.
Population mean is how much? Population mean is how much?
33.752.
33.752. Population standard deviation is how much? 11.35. Now let me type here. Population mean. How much you said? 33 point? You forgot. How much it is? 33.752.
752.
33.752. And standard deviation?
11.359. 359.
11.359. Thank you. 11.359. Please note, these two are called parameters. These two are called parameters. Population characteristics are called parameters. If you go to the school, this will be the performance of the students in the entrance examination. Do you understand? All of you understand? This particular school children's performance in the entrance examination can be judged based on the average and standard deviation. Am I correct or not?
Yes.
Because no, it is normally distributed, and then you plot, and then you can easily understand what percentage of the students will be scoring between any two value. And now go to stat, basic stat, graphical summary. Now take column number 2. Remove this population. Take column number 2 and give OK. Do you see a distribution here? Narendra, you have some noise is coming from your side, so I just muted. So, do you see a distribution, all of you here?
Yes, sir.
This is called sample distribution. What was the name of the distribution earlier? Population distribution. Now it is sample distribution. Remember the mean and standard deviation. Mean is 16.252. Standard deviation is 0.226. Now this is sample distribution. Mean is how much? Standard deviation is how much? Do you remember? Anybody? Forgot, huh? Mean is how much? 16.252. Standard deviation is 0.226. Tell me, mean is how much?
16.252.
10.22.
Standard deviation?
0.22.
0.22?
0.226.
Now, if you use this mean and standard deviation, you get exact probabilities. Am I right? But if you use this mean and standard deviation, do you still get exact probability of the performance of the school children?
No, sir, because that is sorted.
So they are. If you use parameters, you get realistic estimate of the probability. What you currently have is statistics. Do you all understand the difference between parameters and statistics? Parameters always gives realistic probability, but statistics may not give realistic probability. If you want the statistics to give realistic probability, your statistics should be close to parameters. Am I correct?
Yes.
If the statistics are equal to parameters, then what will happen? Your statistics itself can give you realistic estimate of the probability. That is why you all should master the subject called sampling technique. What is the subject?
Sampling technique.
If you know how to take the sample, your statistics will come close to the parameters. If the statistics come close to the parameters, your study will be inexpensive. At the same time, your decision making will be more realistic. All of you understand the subject called sampling technique? The use of sampling technique. We study only 10 or 20 students, but we get a clear picture of the performance of the school. How? By making sure our statistics comes close to parameters. All of you understand?
Yes, sir.
Yes, sir.
But it is not that easy, isn't it? I randomly picked 5 students from first 100, 5 students from second 100. I randomly picked as far as the sample is concerned. See here. What is the problem here means why our statistics is far away from sample. How many sample I have selected?
18.
And all the sample I selected only from some particular section. I have not covered the section properly. My sampling technique is very poor, isn't it? Yes or no?
Yes, sir.
Since my sampling technique is poor, my statistics differed a lot from the parameters and all my decisions can go wrong now. In your business also, many a times you will be expected to take decision by looking at the samples. Am I correct or not? If you know the art of selecting samples where the statistics will come close to the parameters. If statistics come close to the parameters, it is as good as studying the entire population. Do you understand correctly? All of you are following my statement?
Yes, sir.
Next election, which party is going to win the, win in the election? I do a sample study, but my study will give the realistic picture. Why I am able to get the realistic picture? My sampling technique is very strong. Do you get my point? If my sampling technique is strong, whatever I predict will happen. It happened in certain states. Am I correct or not?
Yes.
Sometimes survey result and actual results may be different. The problem is sampling went wrong. The sampling combination should exactly represent the combination of the population. The top 100, and the bottom 100. You should have sample from the top 100 also. You should have sample from the bottom 100 also. You should have sample from the middle 100 also. Now your sample will speak better about the population. Do you understand how the sampling, can speak about the population? The way the population is distributed, same way you must pick up the sample. But now I followed a technique called random sampling, which did not help me at all. Now you have understood 2 things. What are the 2 things you understood? One is population distribution. Another thing is sample distribution. Clear?
Sir, may I ask you one thing, sir?
Yeah, please.
Sir, for an example, you have said that we cannot predict which party is going to win an election. So consider we are having some districts around 32 or 33 districts in Tamil Nadu.
Correct.
So we are collecting a survey of 1,000 people per district.
Yes.
Okay.
Yes,
this is going to be our collective data. So altogether it come around 33,000 of data we will be having. So sampling will be taking 100 from each district. So that would be sufficient for us to predict the result.
Yes. A good question. Sample size is also important. At the same time, 1,000 itself is a big number. Please understand. 1,000 itself is a big number. But how you collect the data? If you collect the data in a biased manner, do you think still your sampling study will help you to understand the reality?
No.
Say, for example, I am asking you, Santosh, which party will you vote? Which party will you cast your vote? Do you think you will tell me the correct answer?
No.
So these are the challenges. These are the challenges. Do you understand?
You are right.
But if you take measures to ensure people share you the information in an unbiased manner. For example, you give a same kind of ballot sheet. Ask people to randomly go and cast their vote. But tell them very clearly that the identity of the voter will not be captured. Now what will happen? Whichever party I want to win, I will exactly cast my vote for that party and then come out of the room. Isn't it?
Right, sir.
Now the second time will give almost a close to realistic prediction. So that means it all depends with it all depends with your sampling technique and also sample size. And in the whole process, you should not be biased at all. Do you understand? You should minimize the chances of bias. All right. Now we understood population distribution. Another one is sample distribution. Please, all of you understand. Now I am going to rename the first section. How I named the first section?
Subgroup 1.
Subgroup 1. And now it is subgroup 2. Now it is subgroup 3. Now it is subgroup 4. Then it is subgroup 5. Then it is subgroup 6. Then it is subgroup 7. Then it is subgroup 8. Then it is subgroup 9. We only have 9. All right. Now 9 subgroups I have. In each subgroup, how many data points I have?
Sample.
How many data I have?
5.
That is called a subgroup size. Subgroup size is how much?
5.
Sometimes people also call it as sample size. Because sample is collected in the form of subgroup. Clear? When sample is collected in the form of subgroup, the subgroup size is the sample size. All right. And now, tell me here, please tell me, for the first subgroup, what will be the average approximately?
16.56.
16 point. Okay, let me take the center value. 16.61.
One.
Now, second subgroup, what is the average? 20.38. Third subgroup, average 25.52. Fourth subgroup,
27.68.
fifth subgroup,
33.87.
Sixth subgroup,
36.59.
then the next one,
42.36.
42.36. Then the next one,
46.73.
46.73. Then the next one.
49.19.
And what are these numbers? 1, 2, 3, 4, 5, 6. How many we have? 1, 2, 3, 4, 5, 6. One is 9 we have, right? Okay. 9 we have. What are these numbers?
Mean. Average. Mean.
Average.
Standard deviation. Subgroup average.
Wait. Subgroup averages. What are these numbers?
Subgroup average.
Let me mention it here, right? And now the distribution of the subgroup averages is called sampling distribution. Distribution of the subgroup averages is called, what is it called? Sampling distribution. Now let me see how the sampling distribution will resemble. Will the sampling distribution resemble like a population? That is what I'm going to find out. Go to stat. basic stat, graphical summary. Now, what is that I want to visualize? Column number 13, isn't it? Let me remove this. Select column number 13. And now I give OK. And now do you see something here? What is this distribution?
Sample distribution.
Sampling distribution. If you say sample, you are wrong. Sample we have already seen. Population we have already seen. What is that we are seeing now?
Sampling distribution.
Sampling distribution. What is the sampling distribution? Distribution of subgroup averages. Distribution of
Subgroup average.
Now look at the mean value. How much is the mean value?
33.21.
What is the standard deviation?
11.53.
Remember this, 33.214, 11.530. Sampling distribution. Mean how much you said?
33.514.
33.214. 33.214. How much is the standard deviation you said?
11.53.
11.53.
11.53. 11.53. Very good. This is sampling distribution. Let us go to our population. Population. Do you see here? Population parameters. Right? Come here.
Nearly same.
Let us compare our statistics now. This is again statistics. Please understand. This is again statistics now. Will this statistics is close to the parameters?
Yes, sir.
Yes, sir.
So, you have not studied the population. You have studied
Sampling distribution.
sampling distribution. This is your study. This is your study. This study gives a clear picture of the population.
Yes, sir.
The way the population is behaving, same way your subgroup average is also behaving. This is called central limit theorem. What is this called?
Central.
Central limit theorem. If you want to take right decision, you must always use this central limit theorem. What is central limit theorem? When you want to collect the data, don't collect data like column number 2. Work like a professional. Work like a professional. You know your population is spreading from 16 to 49, isn't it?
Yes,
The
sir.
population is spreading from 16 to worst thing can also happen, best thing can also happen. And also, and so what happened? You took sample from all regions of the population. Our Santosh said, sir, Chennai has Tamil Nadu has got 32 districts. And one of the district is Chennai district. In Chennai district, there is, main city. There is also outer Chennai. Am I correct, Santosh?
Yes, sir.
So you have to collect data the way actually the population is distributed. If too many people are there in the center part of the Chennai, then your too many samples should come from the center area of the Chennai. You said 1,000 sample, right? Out of the 1,000, 600 should come from the main areas of the Chennai. Because 60% of the people are known to live in the center portion of the Chennai.
Yes.
So 40%, another 20% in the middle or 30% in the middle. Only 10% of the people live in the outskirts. So how the population is distributed, same way I am trying to distribute my sample also. For that I use the technique of subgrouping. And after taking subgroup, I calculate subgroup average and use only the subgroup average to find out the statistics. Look here, mean is 33.25. Standard deviation is 11.53. Still they are not exactly same. But my prediction is close to reality. Understand?
Yes, sir.
Now, one more important statement. With that, I will also close this class. If population is normally distributed. If population is normally distributed, distribution of subgroup averages, distribution of subgroup averages will be normally distributed for any subgroup size. All of you are able to understand my statement?
Yes, sir.
Population is normally distributed. 100% sure that subgroup average is also normally distributed. You don't have to ask anyone. You know population is normally distributed. Subgroup average also normally distributed. Now subgroup size is immaterial. Subgroup size is even 2, subgroup size is 2. Then also no, that will follow normality. If that also follow normality, subgroup statistics will be close to population parameter. Now comes another situation. If population is not distributed normally, population is not distributed normally, then also the distribution of subgroup averages will be normally distributed with sufficiently large subgroup size. Do you understand? Population is not normally distributed. I don't know whether population is binomial or geometrical or whatever distribution. I don't know about population. It can be any distribution. But still, my subgroup averages will compulsorily follow normal distribution. Once I know the distribution, my predictions will come correctly. Do you all agree with me? If the distribution is normal, once you understand, then you can find out the probability. Am I correct or not? Yes or no?
Yes, sir.
We don't know anything about the population, but we know that the distribution of subgroup average will definitely fall normal distribution if I gradually increase the subgroup size from 2 to 3, 3 to 4, 4 to 5. Definitely before the number becomes 2 digits, you will see the curve becoming normal. This is called the central limit theorem. Always the distribution of subgroup averages called the sampling distribution will follow normal distribution. Only requirement is subgroup size should be sufficiently large. If you understand this, don't worry about what kind of distribution your population is. Anyway, your sampling distribution is going to follow what? Come on. Come on, I expect you to answer sometimes, right? Population distribution is not known, but then also my sampling distribution will follow which distribution? Normal distribution. What is the only requirement? Subgroup size should be sufficiently large. If you know this, any problem in the world can be solved using the concept of normal distribution. Is that clear to all of you?
Okay, sir.
So with this, I would like to end today's session. Thank you for allowing me to extend the session up to 9:30. I generally close by 9 o'clock, 8 to 9 only. So now we extended to 9:30. Probably this kind of interesting concepts, it is difficult to teach all of you this kind of interesting concept in the main training because it is going to take a lot of time. And moreover, you must have the patience, interest, and the commitment to learn all these things. Am I correct or not?
Yes, sir.
So only to test whether the participants are really committed or not, certain sessions are scheduled separate. Only interested people will come and we can only teach those people, not everyone. Right? And you all should be proud of your participation here. You learned some good stuff today, and which many of the green belt and the black belt do not know even today. Please take it granted from me. There are black belts coming out from several sources. Yes or no?
Yes, sir.
But at least 90% of them, they do not go to the required depth of, to, to become eligible for the title black belt. But we truly want you to go to the depth and then claim your certificate. And that is why these additional opportunities are created. Please make best use of all these opportunities. And you will definitely see yourself on the top 5% of the black belts in the market, green belts in the market. Do you know you will definitely stand out of the average green belts and average black belts in the market. You will be distinctly better. All right. So I end here. Thank you very much for your participation. Bye-bye.
Thank you.
Thank you, sir.
All right. Thank you, subscribers. I stop.